Hello everyone, here is another interesting question. If the sum of the first n terms of arithmetic progression sequence, we are talking about positive terms, is given by Sn equal to 1 plus 2tn times 1 minus tn, where tn denotes n term of the series. We are asked to find the sum of a and b if t2 squared is equal to the square root of a minus square root of b divided by 4. All right, let's get started. Let's start with S1. S1, that is when n equal to 1. We have S1 to be 1 plus 2 times t1, right? We are replacing n with what? 1 multiplied by 1 minus t1. But you should know that S1 means what? The sum of only the first term. Yeah, you're taking the first term. Because assuming you have 1, 2, 3, 4, 5. If you are asked to find S2, it means what? First term plus the second term. But if they ask you to find S1, sum of only the first term, just step 1 is Sn, which means that S1 is equivalent to T1. T1 means term number 1. So we can confidently replace S1 with T1. And how do we expand this? 1 squared is 1, then 2T1 minus T1 will give us positive T1, then this time that will be minus 2T squared 1. All right. From here, we can make t squared 1 the subject. And how do we do that? Just observe, if you subtract t1 from both sides, it becomes what? 0, right? Here. Equal to 1 minus 2 t squared 1. If you bring this one backward, it becomes positive 2 t squared 1 equal to 1. Then you can divide both sides by 2 and take square root, right? So it means that T1 is equal to, divide both sides by 2, you have 1 over 2, right? And 1 over 2 on the square root. Do not take plus or minus because we are talking about positive terms. All of them are positive. So this is that, or you can simply write it as square root of 1 divided by square root of 2. So we are done with T1. Let's go to T2. Then S2, we are going to substitute n equal to 2. This is equal to 1 plus 2 times t2 multiplied by 1 minus t2. But S2, remember, is term number 1 plus term number 2. So we can write it as term number 1 plus term number 2. This is equal to what? This time, this 1 times 1 is 1. Then this plus that will give us positive t2. Then plus minus, we are multiplying this and that, 2 t2 squared. Yes, this is the expansion. But already, we know that term number 1 is this, right? So we can bring it back. And if you subtract T2 on both sides, you can see that this and this will cancel, definitely. But we have the square root of, let me just write it as 1 over square root of 2. Because square root of 1 is 1, square root of 2 is square root of 2. This is equal to 1 minus 2 t squared 2. I would like to make this the subject, and how do we do that? You can switch this and that, so we have 2t2 squared equal to 1 minus this, what do we call it? 1 divided by the square root of 2. And we can simplify this. This is simply root 2 minus 1, because this time this is root 2 minus 1 divided by root 2, right? So we have 2 t2 squared equal to root 2 minus 1 divided by root 2. We are moving. I think we can multiply the top and the bottom by square root of 2. And where can I do that? Let me see if this space can be sufficient. Well, let me do one thing here to simplify my work. I can remove this 2, right? You know it is multiplying, it is going to divide the other side. Yeah, no problem. We are still having t2 squared. This is equal to, by rationalizing this, you multiply the top by square root of 2. Square root of 2 times square root of 2 will be what? Square root of 4. Minus 1 times square root of 2 is square root of 2. Divide by, if you multiply this by square root of 2, square root of 2 times square root of 2 will be square root of 4, and square root of 4 is 2. 2 times 2 is 4. So the bottom is 4. This is t squared 2, remember. Compared with what we have here. You see that? t2 squared, we have 4 here, we have 4 here. It means that a is 4 and b is 2. But what are we looking for? We are looking for a plus b. Therefore, a plus b is equal to 4 plus 2, and 4 plus 2 is equal to 6. Yeah. Therefore, the solution to this problem is just 6.